Good afternoon, and welcome to today's webinar for meeting National Board requirements with Inspect. My name is Brian Jones, and I am one of the sub-engineers here at Codeware. One of our mechanical engineers, Amber Leonard, and I will be your webinar organizers. Today, we'll take a look at how Inspect can help you manage post-construction activities like rating old equipment, and we'll even touch on some of the history that goes along with understanding how this might affect you and your projects. Before we begin, I want to remind everyone that you can find recordings of prior webinars, handouts, and Q&As at www.codeware.com/webinars. Shortly after today's webinar, its recording will be added to the online archive as well. As with all open discussions, please feel free to ask questions throughout the presentation by typing into the webinar control panel located on the right of your screen. We will try our very best to answer as many questions as we can during the Q&A session, but for those questions that we cannot get to within our time constraint, we will publicly post the answers to online at www.codeware.com/webinars at a later date. I'd also like to bring your attention to the handouts provided for you in the handouts section of the webinar control panel. If you expand that section, you'll find an Inspect brochure along with a promotional offer for 20% off of new Inspect licenses. Now, this offer will only be available for a limited time, so if you would like more information, please email sales@codeware.com. All right, at this time, I'll pass it over to your presenter and our engineering manager, Matt Hyland.
Thank you, Brian, and welcome everybody to this webinar on meeting the National Board requirements using our Inspect program. As Brian had mentioned to you, I'm going to try to get to all of your questions today, or as many as I can, but like he said, if I can't get to it, I'm going to be going through them afterwards, and we're going to go ahead and post them. So I encourage you guys to ask as many questions as you'd like. So today, as you can see in front of you, here's my presentation. And let's get into it. What am I going to be talking about today? So some of the things that I'm going to be covering today are going to be a brief overview excuse me, of our compressed program and our Inspect program. I often get a lot of times, well, is this a new program? Do I need to relearn things? Things like that. So I'm going to actually break down and show you what the differences are between the two programs. I'm then also going to get into some of the NBIC considerations. So we're going to look at re-rating vessels or possibly relocating vessels and some things that we need to know when we're doing either of these activities. Then we're going to get into a little bit of the history of the ASME code. In particular, I'm going to be talking about allowable stress and why this is going. It's good to know some of this and how it can benefit you in your current day-to-day work. Finally, we're also going to do some re-rating using our Inspect program. So we're going to touch on things like the NBIC Interpretation 98-14. We're going to look at brittle fracture and MDMT. We're also going to look at inspection schedules for corrosion and also benefits of modeling the longitudinal welds. Now, I'm also going to try to show you guys what's coming down the pipeline, and that pun was intended. So at the end, if we have time, I'll show you what we've been working on over here at Codeware as well. So let's go ahead and get started. So the first thing I want to do is have an overview of what is our Inspect program and why did we start with this Inspect program. Codeware has been in business for 31 years now, and what we were finding is that our compressed program has been used extensively in the post-construction world. And where it was being used, it was being used to calculate our ASME compliant T-mins. That would then get passed into some custom software to do further analysis. So naturally what we decided to do was we have an Inspect program, which is really an upgrade to compress, which eliminates the need for custom software. So what we did was we combined compressed with our inspection survey data, rules from the NBIC, the API 510, as well as the API 579. We also have B31.3 piping calculations available in our Inspect program as well. Now, one of the nice things about Inspect is that it also shares the same user interface and .cw7 file types that Compress does, so it's a very easy upgrade. One benefit of this is that if you have a fabricator, or if you are a fabricator, you can actually send the vessel file to your owner or your client because they may need it for the mechanical integrity program. Likewise, if you're an owner-operator and you are running Inspect, and it comes time to maybe replace a vessel or run some repairs or some analysis, you can send that CW7 file back to either a designer or a fabricator so they have the exact model and what you need. And finally, our Inspect program also supports new construction design. The reason I mention this is that we do actually have quite a few clients that use our Inspect program. And one of the benefits of this is you can actually take baseline thickness readings as one of the last steps in your fabrication process. Now, I've spoken to a couple of owner operators, and I know the comment comes up is that they wish they could just get a couple of thicknesses when it's being built, so that in 5 years or when they do their inspections, they have a good baseline reading to go off of. So you can actually do this, and you could possibly set up where the inspection points are to be taken as well. And just one little note here before I get into it, Compress represents Codeware's interpretation of the ASME code. Similarly, our Inspect program is Codeware's interpretation of the applicable paragraphs on the NBIC. So with that, let's go ahead and get into it. So let me go through an example. So let me show you the Inspect program, because many of you may have never seen our Inspect program. So I open up Inspect here. Many of you, and I think a lot of you are actually, some of you are Compress users. We actually have 350 of you registered today, so thank you again for attending. But this is our Inspect program. So some of you may say, no, this is Compress. It looks exactly the same. Essentially what we did is it's an upgrade to Compress. So this is actually our piping spool. This is a B31.3 pipe spool. Well, you'll notice here we have a couple of other things modeled on the pipe. I've got corrosion here, I've got metal loss, I've got groove-like flaws, so we can actually start analyzing this for a piping document. But let me switch over to this example here. And this is actually a client vessel that was sent to us years ago. They were so happy with the Compress product, they actually gave us permission to use this for demonstrations and things like that. So this vessel was actually modeled in our Compress program and then loaded into Inspect. Now, a couple of things you may notice about it is up here at the top, you've got your Division 1 document, Division 2, our heat exchanger, but we also have a piping document, which I just touched on. Now, in addition to this, we also have our API 510 menu, which I'm going to be spending quite a bit of time on today, as well as our 579 menu as well. Now, what we can do, I had mentioned, we take thickness or survey data and put on the model. And if I scroll and zoom into this model, I should say, you can see here these black dots on the vessel. And these are what I call CMLs, or more commonly referred to as condition monitoring locations. You may hear the term corrosion monitoring location or thickness monitoring location. Essentially, it's all the same thing. It's just nomenclature that has changed throughout time. And we can even tell you where governing points are on the vessel. Now, because we're using 3D models, we're not using these traditional spreadsheet styles where you have hundreds of vessels or miles of pipeline. You have to try to figure out where this is. We can visually show you on the model. What's very beneficial is that if you are setting up a mechanical integrity program, and this one in particular, great, I can actually access this point. But what if this point was 8 feet above it? Then maybe we need to schedule, bring in some cranes, scaffolding, things like that. Now, when we set up these points, I'm going to go through this with you, and we're going to come back and do this a little bit more in detail, but you'll have a maintenance inspection dialog right here, like so. And this is where we're going to house all of your inspection survey data. So right here are the inputs for the thicknesses. So every one of those black points on the vessel correspond to a cell here. And you can actually copy and paste this information in from Excel or Access databases, things like that. And you can see here I've actually got under my inspections 2 inspections active. I did one in 2010, and the last one was done in 2015. And we'll put some markers in here so you can know there's the governing point, this one, the thickness increase, so maybe we can go back and check that, things like that. We also have options for equipment details here. We can actually fill out information about the equipment. We can set up inspection schedules, put in user-defined fields, notes. And one thing I really like, we can actually upload supporting documents and images. So if you actually want to put a picture of a damage mechanism in the report, we can do that. You just simply click Add File and load it in. And I'll show you in another example what I'm talking about. Then we have inspection details and as well as CML details. So if you have notes for specific areas on the vessel, you can actually link them to the model. We also have corrosion, where we're going to determine your loss of metal. We're going to determine your long-term and short-term corrosion rates. And then finally, we're going to have our calculation tab. Now, one thing to keep in mind when we're doing this work is we have to get a proper team in. And this is, again, where we were seeing our Compress program being used extensively. So when we calculate the team in, it's not just a simplistic UG27 or a UG45 calculation. We have to take into account things like wind and seismic loading. What about MDMT? Liquid levels, static head acting on components. All of these are very iterative in nature, and it affects the team in of the vessel. So what we've done is we've essentially run the TMIN at every single one of those points that you set up. Now, I mentioned to you before, modeling the longitudinal seams on the vessel, we can do that. Well, we take that into account. So if you have vessels possibly built from the 1980s where you had a spot radiograph, you had a 0.85 joint efficiency, we account for that automatically because we know where the seams are. So we might be able to give you more remaining life than you initially thought. So what we do is we click calculate, and we'll go ahead and calculate all the required thicknesses, and I've already gone ahead and done this. Then what we get is when I click on the remaining life, you can see how much life the vessel has remaining. So I showed you the governing point on the vessel. Well, there it is. So this is what our inspect program can do for you. So this is kind of an overview and a little bit of the difference between the compress and the inspect program. Let me switch back to my slide here. Okay, so let's get into some of the other topics here, and I want to talk about the history of the allowable stresses from the ASME code. Now, many of you know that the allowable stress is determined by a simple function. It is the minimum of 2/3 the yield stress, or the ultimate stress of the material divided by the design margin. Now, this design margin has changed throughout time. So in the 1950 edition, this was actually reduced from, the design margin was reduced from 5.0 to 4.0. And at this time, there was no Division 1 or Division 2, which we commonly know today. The ASME code was just the ASME code. That eventually turned into what we know as the Division 1 code. Then the big one was in 1998, and more specifically, the A99 addenda. It reduced the Section 8 Division 1 design margin for new construction from 4.0 to 3.5. Now, this is a huge change for us. Why was that? Because this change increased the Section 8 Division 1 allowable for many of the common materials that we see at typical operating temperatures. One material that comes to mind, I've got it noted here that we've all seen, is SA516 grade 70. The allowable stress from this material went from 17,500 psi to 20,000 psi at 500 degrees Fahrenheit. So that was a huge jump. Okay, and since we're talking a little bit of history, a couple other historic considerations to keep in mind, and this is just so you guys know, there's a couple notable years I want to bring to your attention. 1962, 1968, and 1987 are all notable years. So in 1962, the joint efficiencies changed. So vessels with a code of construction prior to the 1962 code, you may need to utilize what we call user-defined joint efficiencies. It's not a problem. When we model the equipment and inspect, you just simply select user-defined on the joint efficiency, and we can enter that in. Now, one of the big years, 1968. Why was this a big year? Because additional loading considerations were added to UG22. And another big point here, that code additions prior to 1968 are not currently recognized by the API 510. So keep that in the back of your mind. And then finally, 1987. In 1987, the brittle fraction provisions of UCS 66 were added into the code. More specifically, it was actually the 1987 addenda. Now, why is this important? Well, the NBIC recommends that brittle fracture is considered. For more information about this, you can go to the NBIC part 4.4.8.2. And finally, the API 579 may require it before proceeding with certain sections. So if you actually go into the API 579, let's take part 5 or part 6, there's a little bit of verbiage in there that says, if the material is sufficiently tough, you may not need to do this. Now, the way that's worded, it's kind of, it's up to you to determine that. I would recommend you always run this check. What it is in API 579 is a part 3 check. There's a simple checkbox in our dialogues to run it. It doesn't hurt anything, and then you can make sure that the material meets the critical exposure temperature. Okay, but what does all of this mean? I've just talked about allowable stresses. That's great. We've been reducing the design margin. How does this help me today? Well, the question was asked is, can the A99 allowable stress values be used when re-rating equipment built their older codes? The answer to this is yes. The NBIC released Interpretation 98-14, which specifically addresses this. This interpretation is actually available on the National Board website, so I would encourage everybody to go and get it so they have it on record. So what does that mean? The A99 allowable stress values can be used, but only if the equipment meet the following criteria. Let's just go through them. 1, it's suitable for the new service. So what does that mean? You can show by calculation or by some other means that it includes consideration of external loads. It's not in lethal service. Now, for those of you that aren't sure what lethal service is, you can go to paragraph UW2 in the ASME Section 8 Division 1 Code Book, and it defines it there for you. The vessel was originally built to that notable year 1968 code edition or later. It's not in fatigue service, so this is the same as Division 1, and has had a satisfactory operating history. So in other words, you've had no problems with the vessel, things like that. Your current inspection verifies no unrepaired damages are present. What does that mean? Essentially, you have any corroded areas are permitted if the measured thickness is not less than the T-min. So when we go, from a designer, we calculate our required thickness, we then get our design thickness, and then we get our nominal thickness. Sometimes people use a lot thicker plate than they needed because maybe it was out in the yard and they were able to reuse it. So that means you got a lot of extra material there for post-construction activities. And finally, it's also shown to comply with all the provisions from the code from which the increased allowable stresses are taken. So in other words, if we're going to run into the 2015 code, we run the calculations and we make sure there's no code violations that are in effect, things like that. So let's go ahead and show you an example of this and how we can use this interpretation. So if I open up Inspect, I'm going to open up my little sample model here. Now I've gone ahead and set this up. So I've actually modeled this to the 1996 code edition. And what we can do is come up to our codes menu and verify this. So we can select ASME. And you can see here we actually have a database of older codes. So instead of having to install older versions of a software, things like that, you can always use our latest software but still have access to the older code editions. And eventually down the road, you won't be able to install the one program per one edition because it probably won't work on a lot of the later operating systems. Okay, so we're running into the A96 addenda. So I'm going to click on my maintenance inspection. And I'm going to come over here to my Calcs tab, and I'm going to click Calculate. So you're actually going to see it iterate through. So it's iterating through our T-min at every one of those CMLs that I've shown you. And then what we're going to do is determine the remaining life. Okay, so it's done here. So there's a couple things. You can see here under the components, we have some things highlighted in red. This is marked in orange. What does this mean? Well, down here on the bottom right, you'll see a color legend. Red means it's below the minimum thickness or minimum required. That's a problem. Orange means you have less than 3 years remaining life. So just really a warning for the mechanical integrity planning of the vessel. So if I click on remaining life, you can see here I'm in the red, I'm below 0 years, so technically I'm not in compliance and I should be shutting this vessel down. And then my other point has just over 2.5 years remaining. So what can we do? Well, I had gone through all of the steps before. So, we'll go through them and assume, okay, we've met all the criteria from Interpretation 98-14. So what we can do is then come up here to my codes menu, select ASME, and change this to the 2015 code edition, like so. Click OK. And I'm going to click on my maintenance inspection again. I'm going to rerun the calculations. So I'll click Calculate. So in other words, I just took advantage of that higher allowable stress because I did build this vessel out of SA 516 grade 70, which I probably see in 85, 90% of the vessels that come across my desk. So just by simply meeting the criteria, that interpretation, changing the code edition, you can see here I have no red left, which means, okay, nothing's in the negative, but I have a little bit of orange. So what is that? So when I click on remaining life, you can see here I went from I have to actually shut this vessel down to just under 3 years. So that's how we can actually use some of these interpretations to meet the national board requirements. Okay, now I'm going to come back to this later because I'm going to show us how we can do some re-rating as well. But that's an example of how we could use that interpretation 98-14. Again, I encourage you all to go to the national board website and get that interpretation. Okay, so the next thing we're going to look at are the NBIC considerations. Now I've got this broken up in 2 columns here. I have re-rating equipment and I have relocating equipment. So let's go through the re-rating first. Now when I say re-rating, I've heard the term derating, re-rating. It's essentially if we have to drop the pressure. We can also do the flip side. We're running a what-if scenario, so maybe you have to increase temperature or pressure. Sometimes we do have to do that. But what are some of the things that we need to consider when we're re-rating equipment? First off is, do you have all of the vessel information? And what I mean by that is, do you have drawings, U-forms, possibly WPS numbers, etc.? Essentially, do you have all the original design data? If not, are you able to get them? Is the metallurgy still acceptable? Now, a couple of things when I'm talking about metallurgy, and what do I mean is it still acceptable? Well, a couple things to look at is it susceptible to hydrogen attack? Is self-irradiation corrosion going to be an issue? Or is it stress corrosion cracking? Those are all things we want to consider when we're talking about the metallurgy and if it's still acceptable. Is this a service change? Now this is a big one. What about if we change the content-specific gravity or liquid level? This might increase the static head that's having to be supported on the supports, the static head added to the nozzles, or any components that are affected by that as well. And finally, does the vessel MAWP allow for a proposed coincident pressure and temperature? So these are just a few things we need to look at when we're re-rating equipment. Then, what if we're relocating equipment? Relocating equipment usually involves all of the re-rating considerations that I actually just spoke about, plus some additional things. One of the biggest ones is, does the relocated equipment cross a jurisdictional boundary? And would this require approval? Does the jurisdiction involve a new owner? These requirements are going to vary by jurisdiction. So I would check with the local authorities and see what's involved in transferring or if you're moving equipment to and from places. Things like external loading, such as wind and seismic, may have changed. So all U2G loads acting on the equipment must be considered. A really good example would be, let's say we have a vessel that is currently in Texas, or let's say here in Florida where I am, and we're moving it out to California. Well, the seismic maps change and the seismic loads are going to be different. So those are one thing that we're going to have to check there. The other thing is the piping loads acting on the nozzles aren't likely to be the same as the original design. So these must be checked as well. So what we can do, we can actually open up the nozzles, we can go to our WRC local stress dialogues, and we can check the stresses due to 107, 297, 537, and we also have finite element analysis as well to help you guys check this. And the last point is your MDMT. Colder locations could cause MDMT issues. So again, I'll refer you back to UCS 66 for more information on that. So let's just summarize what I just spoke about. So the entire vessel, including supports and piping attachments, must be considered. Items such as the MDMT, nozzles, flanges, cone junctures, and wind seismic often govern this as well. So what does that all mean? Well, my last point here is a simplistic T-min calculation considering only UG27 or UG45 just isn't adequate to demonstrate the mechanical integrity. I'm seeing more and more emphasis put on mechanical integrity nowadays. So again, we want to make sure that we get that proper T-min because the entire analysis, whether you're doing 579 or 510, really depend on that T-min. And just a note about that, and this actually comes out of the 510, is that if you do have differing corrosion rates, let's say between a nozzle and its parent component, whether it's a shell, a head, or a transition, can cause the mode of failure to change throughout time. This is actually one of the reasons why the API 510 mentions that the remaining life calculations should be iterative in nature. Now, I just said a lot there, so I'm going to repeat myself. So if you have differing corrosion rates between a nozzle and its parent shell or parent component, this can cause the mode of failure to change throughout time, which is one of the reasons why API specifically mentions that the remaining life calculation should be iterative. Now, this is going to be the same for things like cone junctures and nozzles. I typically see this more so with nozzles and cone junctures, but it is possible for that to happen as well. All right, so let's do another example here. And what we're going to do, let's re-rate some equipment using inspect. So what are we going to do? We're going to gather all of the relevant information and create the inspect model. Now this is a good point here. Because our inspect program shares the same user interface as compress, we could actually just take the compress models and load them into inspect. So again, if you're an owner operator and you've been working with a particular fabricator for a long time, they likely have the compress model. So why don't you ask them for it? If not, when it's time for replacement, simply put in the specifications. And then you could have the exact model that was built for fabrication for your mechanical integrity program. It's really easy just to call them and ask for them. And likewise, if you ever have to have rework done or anything like that, you can simply send that model back to the fabricator. We're then going to select the code edition for the analysis. So I had showed you that inspect provides a large number of older codes to choose from. And just a note here, all of this applies to Division 1 for vessels that are not operating in the creep range. Okay, I'm going to repeat this, not operating in the creep range. If you want more information about this, you can see NBIC table 4.4.8.1. Assuming that we may not have the compressed file or the inspect file, we can model the equipment and we're going to add the applicable building codes, and then we're going to set up our CML or our inspection points. So let's go ahead and do that. So let me open inspect back up. And what I'm going to do is open up a Division 1 document right here. And I'm actually going to model something very, very quickly just for the purposes of demonstration. So I'll go ahead here, model my head. All right, I'll put a nozzle on this. Attach my flange onto it. And I'll just put it on the bottom seam. Okay, so let's say this is our vessel that we've got here. Now you can see here I have the longitudinal seams modeled, and in our program we actually stagger them by 30 degrees by default. So again, this is a key point, is that we want to make sure we locate these on the vessel. So when you do the modeling, up here at the top you'll see this long seams button, and you can click on it. Now it'll open up a 2D shell rollout of the vessel. So you can see here our shells, there's our nozzle, but you can start adjusting them either on plate length, equal spacing, or what I like to do, angular position. So maybe you have them spread at 90 or 180, whatever your standard is, you can simply locate them like that, like so, and click OK, and they'll adjust for us automatically. But let's go ahead and set up our first inspection, or our baseline inspection. So what are we going to do? We're going to come up here to our API 510 menu, and we're going to select API 510 Maintenance Inspection. Now this is our new inspection details dialog. So the couple things that we have to fill out here are, one, what are the inspections you'd like to perform? You know, we're going to do a thickness inspection, an internal and an external inspection. And then we need to know what the inspection date is. Now you can either type in the inspection date here, or what I usually do, if you just click the pull down menu here, you can click on the headings and you can actually go back to a specific year. So let's go back to 2000 and we'll do today's date, and we'll select that as new equipment. So I'll go ahead and click next. And then I'll ask us for the UG 116 design marking. So in other words, what design or what pressures and temperatures are we going to use for the calculations. So I'll go ahead and click OK. And then we open up our maintenance inspection dialog. Now it initially is going to come up as a blank screen because we need to actually set up the CML location. And just a note about this, a couple questions that I usually get when I talk about inspect is, where should I put the CML placement? You know, is there a best practice to put CMLs? It really depends on a couple of things. One, it's going to depend on the method of taking the reading. It's also going to depend on the expectation of general or local corrosion. Are there any expected damage mechanisms to arise? Is the process fluid changing in composition or phase? Is there a pressure or temperature change along the vessel? Sometimes we have vessels that actually have multiple pressure chambers on them. Is there a flow rate change, or is the flow rate changing? And one of the big ones is there equipment blocking a location? Will you need scaffolding to get to it? Things like that. So the CML placement really depends on the location of the vessel, the service that it's in, and your mechanical integrity objectives. So I hope that helped, but those are a couple points to keep in mind when you're looking to locate them. Now what we can do here in Inspect is up here under the Edit menu, we can actually automatically populate our CMLs. So I'm going to select this right here. And what this allows us to do is set them up. So I'm going to do a starting elevation of 2 inches above the skirt, and we're going to go every 36 inches, so 3 feet. And I'll place them around the seams as well, because again, we want to make sure we account for that joint efficiency adjustment that we get credit for. So that when I click populate, you can see here the grid's been populated. Now you can remove areas, you can add areas, so you can always add in inspection points here. Now this is where you can either fill out the thicknesses, you can copy and paste them in, perhaps one of your data loggers, I believe Olympus actually exports their data to Excel format. You can copy and paste that in. But what I'm going to do is just come up here to my edit menu and select set CML thickness to parent nominal. I'll click yes here, and it will come over. So there, I've actually just gone ahead. Oh, and this is just asking us if we'd like to switch the rating mode right now, and I'll say yes. And as you can see, there are my inspection points on the vessel. So I've gone ahead and set this up. So that's how we would go ahead and we would model the equipment and we would set up our inspection points. Now I'm actually going to switch over to this inspect sample here because the purpose of this is to do a re-rate, and I actually have the data here for this that way. So let's say we're re-rating this vessel. What we're going to do is come into our maintenance inspection dialog here. Now, I showed you before that our remaining life was just under 3 years, but if you actually look around here, we can investigate. Well, the point above it's over 32, 75, 17, 32, over 6. There's not a lot of life. We have a lot more life surrounding this area, so what can we do? Well, maybe we can actually derate the vessel. And how we can do that is come back to our input display here and click on equipment details. So when I set up the inspection dialog, it asks us for our UG 116 required markings, and that's actually located right here. So what I can do is put in a user-defined pressure, and let's say I know this was designed at 100 psi. Perhaps it's been running at 50. Your safety valves are set at 60. So what if we were to derate this to 75 psi? What would that do for the remaining life? I can enter in 75, come back to my calculate. Type in 0 there, and I can recalculate my required thickness here. And just based on dropping it by 25 psi, we can see what's going on. Or if you've actually measured the operating conditions of the vessel, that's even better. You can see exactly what it's been operating at. So just based on that, I'll just let it finish here. Okay, so good news is we have nothing indicating there's less than remaining life or it's out of life. The remaining life went from just under 3 years to just over 14 years. So by being able to make a very quick one input change, I could see would this actually help with any mechanical integrity planning, things like that. Okay, so we've done that. So let's have a look at the scheduling. Before I do that, we're going to come back to the input screen. Now I showed you guys before, we do have a way of uploading supporting documents and images. Since I'm going to run the report, I'll show you this. So let's add an image to this report. So I can click on the supporting documents and images and then click add file right here. And what I'll do is come up here and add my pitting image, and now my image has been added to the report. So then when I click OK, now we can run the calculation report. So what we'll do is we'll come up here to our action menu, select perform code calculations, and it's actually going to run through the remaining life calculations, and then it's going to run through the code calculations as well. Now, for many of you that are using Compress, when I get to the report, it's going to be the same report that you're always used to, but we're going to have another report in there for you. All right. So this is actually going to generate in the HTML version of the report. This is what I typically like to use. Again, we can also produce these in PDF, so if you have to send this off to an auditor or anything like that, you can generate a PDF. So again, here's our output report. You've got our summary reports and then our detailed calculations down below. So if an inspector asks you, how did you determine the team in, you can actually come in here and you can review the report and you can see, here are our team ins and here's how we determined it. This just makes sure that we're in compliance with the national board. But one thing in here is the inspection report that I ran right here. So here's our inspection report. You can see here, I actually just put an image of pitting here. So again, if you're out on, maybe you're looking at something and you notice there is some pitting, take a picture with your phone and you can actually upload it to the report afterwards as well. Now in the report at the top here, it's going to be a summary of measured thicknesses, things like that. Your shell courses, here's your shell measurements. Now actually, we had a user request this a couple of years ago, but you can actually generate these tables blank too. So if you do want to take them out and possibly fill them out by hand and make notes, you can actually fill out these thickness tables or have them generate blank forms for you as well. 2D shell rollout with your measurements on it. Again, there's our governing point, nozzle placements. Now down here at the bottom, you're going to have your remaining life calculations. So you can see here our governing component type is nozzle number 3. It's due to corrosion on cylinder number 2. We're basing it on short-term corrosion rate. Here's the pressure and temperature I ran the calculations at. Then we're going to calculate is our corrosion rate right here. And then from there, we can calculate the remaining life. And then from there, right below, we can give you your intervals for your thickness inspection, your internal inspection, and your external inspection, because that's what we asked Inspect to do. And then as well, we can also determine the projected retirement date for you as well. So when this vessel is completely out of life, we'll be able to tell you, so you can either start budgeting or maybe look at derating that vessel as well. So that's how we'll help you guys schedule everything. So if I click back here and I come back to the model, there's a couple of other things that I want to show you since we're here. One is under this API 510 menu, there's an option here to save a projected vessel state. Now, what this does is it saves a file in the state of it was fully corroded. So in other words, it validates your final remaining life results. So if somebody asks you, can you please verify what you've just shown me? You can save it in that state. Essentially, this is what the vessel would look like if we use the current corrosion rates, okay? So that's available for you. Now, one of the other features that I didn't get a chance to share, which I'm going to show you now, is what we call our project feature. So I've looked at one vessel, but these vessels are all hooked up to piping, other vessels, tanks, things like that. If you right click up here, you can actually, this menu will appear and we can select project. And over here on the left, and you can move this around, it's dockable. As you can see here, here's our inspect samples folder. So I've got 579 examples, 510 examples. You can actually model a process loop, or what most people refer to as a corrosion loop. And I've got some sample files in here, and it's not just inspect files. If you want to upload any U forms, if you want to upload inspection reports, pictures, anything like that, you can associate it all. So this is kind of like your work folder, so you can put it all in one location. But one thing I really like, and let's assume this is our corrosion loop, you can right click on this folder and select vessel data chart. And this note here is just saying, I have an unsaved document open. That's fine. I'm just going to click OK here. And you can have a look at the vessel data chart, and we can actually customize the information you want to see here. So down here on the left, if I click Customize Table, we can have a look here. So what I'm interested in is what's the governing component, what's the component type, and then what's your date of next inspections. And I'll remove that. And scheduled retirement date. So when I click OK, there we go. So all those files or vessels that I have saved in that folder, you can come in here and quickly see when's the projected retirement date of all of them, when's your date of next thickness inspection, and what's the governing component. So if you find out that, vessel A is going to be out of life in 6 months or a year, you can actually then go and open up that specific file, and you can drill down and see, is there something we can do with it, or can we derate it? Are we just replacing a nozzle? The nice thing about that is that if you do replace that nozzle, things like that, you could then see what the next governing component is. So you're not, okay, once we fix that, we've only got 1 month left for this one. So you're able to see generally and plan your mechanical integrity activities accordingly. All right, so since we're on the topic of re-rating, one other thing that I wanted to touch on was, what if we have nozzles that we don't want to replace and, they're still failing? I'll open up this example here. This is my Appendix 1-10 example. Appendix 1-10 was actually derived from the building method. It was the basis of the new Division 2 Part 4.5 nozzle rules. And it is an alternative rule that is available in the code, or a set of rules, I should say. So if you right-click on this nozzle, we'll open it up, and I'll go to the second screen, and we're going to have a look at our status bar down here. And you can see here, the UG37 rules, our area available is about 1.2 square inches, but we're requiring 1.5. So this is technically not in code compliance. So what can we do? Well, if we're running this to the later code editions, what we could do is possibly use the Appendix 1-10 rules in lieu of UG37. So how can we do that? Well, we simply click Previous here, click on our calculation options in the bottom left-hand corner, and I'm going to select the option, Use Appendix 1-10 in lieu of UG37. Click OK. Click Next, and you're going to see now, instead of having your areas reported, you're going to have stresses. You're going to have a primary stress calculated, it's 23,423, and an allowable stress of 25,650. So this technically now passes, and it's a Division 1 vessel. Now, why is this a benefit? Well, instead of looking at the area replacement rules and potentially having to introduce extra welding by adding reinforcing pads, extra WPS forms, things like that, you can actually use the existing nozzle configuration and still meet code. So that's just a trick to use. So if you have nozzles that are being governed by area replacement, try switching it to 1-10 and see if that helps for you. Okay, So let's go ahead and summarize everything that I just showed you. So our inspect models calculate retirement dates and inspection schedules for you. Now this is very beneficial for vessels with joint efficiencies less than 1.0. So in other words, if they're spot RT. So typically if you have a lot of vessels in your plant that were from the 1980s, etc., that's going to benefit them. Or whenever the maximum corrosion occurs away from a category A seam. A category A seam is a longitudinal seam on the vessel. There's 4 types. There's A, B, C, and D. For more information in section UW12 in the ASME codebook, they have this nice little image of a vessel, and they describe to you what the different categories are. Our inspect program follows the API 510, which is the same as the NBIC part 4.4.7.2 paragraph K. But what about regions where the measured thicknesses are less than the T-min calculated by API 510 or the NBIC? Now, if it's permitted in your jurisdiction, API 579, or more commonly referred to as fitness for service, can actually be used. Now, fitness for service deals with local damage mechanisms that are not covered by the ASME code. Now, I showed you at the beginning with that piece of pipe, we had pitting, local metal loss, general metal loss. Those are what we call damage mechanisms. Now, I'm actually going to be doing another webinar on fitness to service. I believe at the end of May we have it scheduled because that's going to take an entire session as well to cover it. So I'd actively encourage you guys to attend that as well. Now, before I move on to the next slide, I'm going to run a quick polling question for you guys. And the question is, do you guys want to see what's coming up in the program? Let you guys know what we're working on over here. I always get questions, hey, what's coming in next release? Well, let me go ahead and launch this. So what I want to know is, do you guys want to see what's coming in the next version of Inspect? So I'll give you guys 30 seconds to answer that. All right, I'll give it a few more seconds because not everybody's voted. All right, I'll go ahead and close that. And I'll go ahead and share that with you guys. So 46% of you say I do, 28% of you say I really do, and 27% of you want me to hurry up and show you. So with that, let's go ahead and show you what's coming. So if I click the next slide, now I mentioned before piping, the pun intended. This is actually a full pipe run shown in our Inspect program. So for those of you that have asked us about piping, here is a full pipeline that we're going to be able to load in. Now, if you're curious where we got this, this was actually exported from this program. This is AutoCAD Plant 3D. This is a PCF file that I had exported and brought into our Inspect program. So in addition to handling your vessels, your heat exchangers, we're going to be handling a lot more piping for you guys in the builds to come. So I'm really excited about this, but let me actually show you the new build. So let's minimize this. And let me actually pull up the new build. So here's our latest in-house build, and here's actually that pipe run that I just showed you on the screen. Now I went ahead and changed the background because I like the blue. What you can see there's your elbows, your bends, different elevations, things like that. So that's coming. So what else is coming? So for those of you that have keen eye, it is Easter weekend, so I got a couple of Easter eggs hidden in here. Some of you, and I know a lot of compressed users are actually watching this, and you may see down the bottom left-hand corner, you see 2 files called Type 1 jacket and a Type 2 jacket. Well, if I click on this, there's a Type 1 jacket modeled and compressed with a nozzle penetrating the shell. So this is going to be coming out for you guys as well as our Type 2 jacket as well. So again, here's a couple sample files I put together for today to show you guys as well. Now, I do have one other Easter egg for you guys, and I'm wondering if anybody noticed it. It's actually in the top right-hand corner, or left-hand corner, I should say. So I showed you before, we have a Division 1 document, Division 2 document, we've got a heat exchanger document, and a B31.3 piping document. But we have a document with a T in it. What does that stand for? That's going to be your API 653 tank document. So we're going to be handling all of your fixed equipment. And that actually leads me into my next discussion that I want to talk about is integration. Now, those of you that have attended previous webinars, you've heard me talk about our solid modeling capabilities, things like that, where I think the industry is going in the future. And one of the things I want to bring up is integration. Instead of having little bits, little itty programs that, this spreadsheet calculates this or this program does this, it's very, very hard to use. We're keeping everything in one program. So you don't need to have multiple programs to do all the jobs you need to in your plant. This is all going to be available for 3D as well. So if you are working in plant layouts, you'll be able to export this out to your plant layouts, whether it's going to be a plant layout possibly in SolidWorks or SolidPlant, Autodesk Inventor, or AutoCAD Plant 3D, things like that. That's going to be available. And you really need a software that can allow multiple teams to work together that might not all be in the same location. Because very often you have the vessel guys in one area, the piping guys in another. Well, they can interact right now and still use one program. So this is what's coming to you guys. So I'm really excited about this. I hope you guys are as well, but this is what's coming down. So let me just show you this one more time because I think it's cool. Our little pipe system, again, this was exported from AutoCAD Plant 3D right here. Okay, guys, so with that, I hope you enjoyed all the little Easter eggs I showed you, everything that's coming. I hope you found that very beneficial for you as well. But at this point, what I want to do is open it up for a little Q&A session. So Amber, did any questions come in during the presentation?
Yes, we do have a few questions. First, if I don't have a thickness survey, can I manually input a corrosion rate?
Oh, very good question. Yes, actually you can. I am sorry, I forgot to mention that to you. Let me go open up Inspect for you. I'll go through a couple other options. If you don't have a thickness survey, what we can do is open up the maintenance inspection dialog right here. And up into the options, we can select calculation options right here. And right down here in the middle, there's an option for a user-defined corrosion rate. You can select this, you can enter in your corrosion rate, and then you can fill out the calculation. So yes, you can input a corrosion rate.
Does Inspect do risk-based inspection?
Risk-based inspection, yes, commonly referred to as RBI. Not currently, but this is something that we are looking into potentially in the future is to getting into the RBI area. So not at the moment.
What edition of API 510 is included in Inspect, and can I change the editions used?
Another very good question. Inspect currently has all of the latest additions from the API, whether it's the API 510 or the 579, because when we started this program, we were actually using the latest that were available. So right now, we're just using the latest ones, but I'd always recommend to use the latest standards anyways. So those are what we use.
Does Inspect provide any sort of control over the inspection data to prevent accidental changes?
Accidental changes, yes. Let me actually open up my model again. We actually have the ability to, I guess, set up accounts or do account management. Under our maintenance inspection dialog right here, you'll see data security, and you'll also see a little lock here. Now I went ahead and actually already logged in, but you can actually set up permissions. So you can set up so maybe certain inspectors only have access to the latest inspections, or they don't have the ability to change any of the models, so the model itself is fixed. So there are ways to set up user permissions for each of your users as well.
How do we add photos of damages to the Inspect file?
All right, let me just go now here. Oh, I had actually shown you this earlier, but I'll just go through it again. So if you want to add a photo into the inspect report, what you would do is under display on the input, there's an option here for equipment details. And what you'll do is come over here where it says supporting documents and images and click on it. And then from here, you can click add file, locate the file, click OK, and it will be added here for you. So I've already gone ahead and added that one. So that's where you'll go to add in your images. You can also add them in the CML details as well. So for example, on the governing CML, if you'd like, you can also add an image. Maybe you're out inspecting that area, you can take an image of that area and you can insert it for that CML as well.
Okay, we also have another related question to that. Is there a limit to what file type can be attached to the Inspect file? In addition, is there a limit to how many files can be added?
No, that's actually a very good question. Not that I have found so far. So no, you can actually upload as many file format types as you'd like right now. So we don't limit that at all.
What if my jurisdiction does not allow Appendix 1-10?
Yes, very good question. That has come up once or twice. The jurisdiction really has final say on what we can do with all these rules. Now, the NBIC is actually accepted in more states than the ASME code is, believe it or not, for those clients in the US. If your jurisdiction does not allow Appendix 1-10, that's just something that they will not allow, and unfortunately, there's not a lot we can do with that one. So you might want to work with them and see if there's an alternative method. Perhaps they would accept FEA, again, which you have available to you. If not, maybe you could try a different type of analysis for that nozzle. So it's really dependent on the jurisdiction. Now, not a lot of them have problems with the 1-10 analysis, but it's really dependent on that jurisdiction.
Does API 579 include cracks?
Yeah, actually the API 579 includes cracks. I think maybe the question was actually, does inspect include the Part 9 cracks? We currently do not address cracks. That is something we have talked about over here as well. So right now what we have are Parts 3, which is our brittle fracture assessment, 4, 5, and 6 for our API 579 module.
What does rating mean in the bottom right corner?
Oh, and our status bar, yes. Actually, if you notice down here on the bottom right, you'll see rating, US, Div 1 in 2015. This is what I call the status bar. In our inspect program and our compress program, we actually have two modes of operation. If you right click on any of these, you can switch between them. The rating stands for rating mode. So in our design mode, when we're modeling equipment, we're actually checking for thicknesses, things like that, and we'll actually enforce them so that you don't accidentally let something out to the shop that doesn't meet an ASME thickness. On the flip side of that, we have what we call a rating mode, and this allows us to put in actual thicknesses of the geometry without changing them. So in other words, we'll be able to derate pressure, things like that. So that's really what the difference is between the two. Since I'm on the topic, the US, that stands for units. We also have metric units available. Division 1, Division 2, it's a little shortcut there. And the 2015 is the latest code year, and this is just an easy way to switch between the previous editions within the software. So again, it's nice being able to have all of those additions in one place, so you don't need to go and install, the 2000 version to get the 2000 code, things like that.
Okay, we have one last question for the session. What benefit does Inspect offer over our in-house spreadsheets?
That question actually comes up quite a bit when I'm talking with clients, and this kind of goes back to the integration. One of the benefits about moving away from in-house spreadsheets is you don't have to maintain them. We here at Codeware, this is what we do. We are always in depth with the codes. We maintain our code databases. We're always working on features and ways and productivity tools to make your jobs a lot easier. And again, all of our programs talk to one another. So our inspect and our compress program talk to one another. We're going to be able to handle all of your fixed equipment. So it's really about the integration and moving forward, allowing us to do all the maintenance for you that way and maintaining these databases and code calculations. All right, so Amber, thank you very much for those questions. And again, I'd like to thank everybody for attending. I hope you found this beneficial. Again, if I didn't get to your question today, don't worry, I'll be going through them afterwards. But I'd like to wish everybody a very happy Easter weekend. And I look forward to hearing your comments, questions, concerns from you as well. But on that note, I'm going to turn it back over to Brian, and everybody have a wonderful weekend.
Thank you again for attending this webinar with us. If you haven't already, please take a moment to download the Inspect brochure and the 20% off Inspect promotional offer available in the handouts section of the webinar control panel. If you are interested in receiving a quote to either upgrade your existing compressed licensing to Inspect or purchasing a new Inspect license, please email sales@codeware.com or call 941-927-2670. Within the next few days, we will send out an email notifying all of the attendees when we've posted this webinar to the online archive. At that time, the webinar recording, handouts, and the Q&A will all be available at www.codeware.com/webinars. And while you're there, you can also register for future webinars. We'll see you next time.